Hello, good afternoon. I'm Kern Sibbald, and I'd like to talk to you today about Bacula, which is a network backup program. I have to apologize because I'm running on a rather old machine that's 700 megahertz and has only 256 megabytes of memory. And meanwhile, the SUSE Zen updater is eating my whole CPU, which you can see that down there sort of toward the left. And so everything's going extremely slowly here. Hopefully we'll get the presentation up shortly. I tried to kill it off, but I didn't succeed. Okay. Oh well, it's still doing its thing, but I think we'll be able to get on with the presentation. Okay, here we go. Before I start, could I see a show of hands of people who are already using Bacula or who have tested it? Oh, well, thank you. A good number of you. If all goes well, at the end, I'll be able to give a live demo, and the updater will have stopped these things, and we can show you exactly what happens in real time, and perhaps I can even show you some things that you haven't seen with Bacula yet. One of the Bacula developers asked in a conference one time, what do you do for backups, or do you do backups? And he got all the answers that you see up there. And even if you answer, yes, I do daily backups with a good backup program, Bacula could potentially resolve a lot of the problems that you have. It can easily help you find and restore files through a GUI interface. You can restore to any point in time, providing, of course, you've made a backup at that point in time. It helps a lot in knowing what you've backed up and when. And that's not so easy if you're using TAR or some other system. And finally, well, not finally, but another thing is if you have a fairly large shop, Bacula scales very well. In fact, there's one company in the United States that's backing up 2,000 machines with Bacula. And finally, Bacula has a bare metal recovery, which can help you in a total disaster. Bare metal recovery is a non-trivial thing, and hopefully someday we can get the Linux distributors to cooperate a little bit more and get a better recovery disk for everyone. Bacula is a network backup solution, which means everything goes on is communicated from the various daemons via the backup, via the network. It's designed to be portable to many operating systems, and I'll give you an example. Originally, the project goals were, as you see up there, and they still hold pretty well. Today, it runs from PCs up to mainframes, and somebody has told me that he's writing a client for a Palm, which will be interesting. We already have a lot of enterprise features, some of which I'll describe to you in a few minutes. And probably what should have been number one on the list is we would like to make sure that, providing you have the right hardware and you keep a copy of the software around, that Bacula can read your old backup tapes for at least 30 years. And the last one, we have a free and open source license, GPL version 2, with a few clarifications that just help explain things. Bacula is a name that John Walker, one of the original founders of the project with myself, devised, and it comes from backup and Dracula. And Dracula comes from the fact that Bacula comes in the middle of the night and it sucks the vital essence out of your computer. And so it's a simple play on words. I started the project in January of 2000, worked on it for a little bit more than 2 years before I felt it was ready, and then released it to SourceForge in April of 2002, and then you see a few other dates there. The project's not large, but still we have a good number of project members on SourceForge, 41. There's currently 14, one more than is listed here, developers who have SVN subversion access, write access, and originally there were 35 developers that had access to CVS. About a month ago we changed, and I'll explain the difference there. A few of the mailing lists, you can see they're listed with the number of people that have subscribed to them. And then the downloads for a few of the different versions. The very first version that I released to the public was version 1.16, and I was pretty surprised not very many people downloaded it. On afterthought, it's pretty obvious because it's a new program that has a totally different tape format. Even though it's open, it's not a typical tar or backup format. However, the last major version before the current one was 1.3811, and that's you see the number 12,000 some downloads. Not huge for most projects. However, that's about twice of what Amanda is getting for downloads, so I'm quite happy. Amanda is supposed to be the most popular open source backup program. Now, Bacula has 6 components, 6 major components, and I'm going to go through them one at a time. I'm doing kind of a brief overview because Bacula is so large I can't possibly tell you about everything. The fundamental philosophy of Bacula is that the control is centralized, and the control and administration for the most part, in the director. Okay? It has a concept of a job. It's the basic unit that the director deals with, which is a backup of one client and one set of files. Okay? And the director does all the scheduling. It has its own internal scheduling, and it creates jobs, supervises them, distributes the output where you want it to go, etc. It also maintains a catalog, which is a SQL catalog. I'll talk a little bit more about that. That allows you to very quickly find where files are and which files you back up, etc. Normally, unless you're in a very large shop, you'll have one copy of the director. Directors don't typically work very well together. The second component is the file daemon, or often we call it the client. As its name implies, it backs up and restores files. It runs on each client machine, communicates over the network, okay, with the director and the storage daemon, and as you might imagine, it needs access to all files on the system, so it must run as root or a local system or something like that, depending on your operating system. The code for the file daemon, and in fact for all of Bacula, is common code, but there are little pieces of it, particularly in the file daemon, that are specialized to each operating system, because there'll be differences even across Unix machines for access control lists, and of course Windows has its own way of accessing files and permissions. Typically you have a lot of file daemons, okay, for one director, at least one for each machine that you're going to back up. The storage daemon is another important component, and it's the piece, the process that manages the media, and it reads and writes to disk, tape, DVD, and USB is what we support now. Normally the storage daemon waits until the director contacts it and authorizes to run a job, and then it'll accept information, data. Say you're doing a backup, it'll accept data from the file daemon, and if it's doing a restore, it'll send data back to the file daemon. If it's doing what we call a migration job, it'll handle reading and writing the data itself without interaction of the file daemon. While it's doing a backup, It also sends the storage location where it put the information on disk or tape to the director, which will then put it into the catalog. So a storage daemon and a file daemon don't directly access the catalog. Typically you have one storage daemon per director, but a lot of people run several. They have several machines with tape drives on them. The console is probably the most important piece for users and administrators because it allows you to communicate with the director and control it. You can do virtually everything in it. If you want, you can start jobs, you can review the output that was produced by each job, and you can query the database. There are quite a number of consoles available. The Beat console is a TTY interface, which is very useful if you're SSHing into your site from someplace and you don't have a really fast communications line. There's a WX widgets that runs on Linux, Unix, and Windows. It could also run on Mac OS, but I don't know if anybody's tried it. We have a GNOME or GNOME interface that is pretty much deprecated now. It was never developed fully. And then there are several web interfaces, one of which I hope to show you at the end of this presentation. And currently I'm working on a really comprehensive console that is being developed in Qt4. And it's called the Bacula Administration Tool, or BAT. And one of the features that you can have for consoles are what we call restricted consoles that allow users to see and start or interact only with jobs that concern, that are authorized for them, for example, for their client. The one component that we use that was not written by the Bacula team is the catalog database. We interface to 3 open source databases, MySQL, PostgreSQL, and SQLite. SQLite is not recommended really for serious production work, but it's very useful because it's compiled in and has no administration, so it's very simple for testing. I believe Bacula is the only product that uses an SQL database, although I've been told that IBM's Tivoli has certain SQL commands. It has the disadvantage that things can sometimes be slow because you're dealing with a big database and it's not specific code written to deal with Bacula, but on the other hand, it provides enormous capability for users to interface to the information. The catalog database allows us to track jobs and figure out when they were run, and particularly where the files were stored on the tape or the disk, allowing rapid restores of your data. And as I said, you can either through Bacula or through programs that you write yourself, query the database and get a tremendous amount of information. Bacula, the director, in fact, has built into it pruning of the database records via retention periods that you set yourself, so that the database, once you've reached your retention periods, typically 6 months or a year, the database will tend to remain stable in size. And if you are doing scaling with a huge number of machines, Bacula will interface to several databases, although we only support one database of any kind at a time, current time. And then the last component that I won't talk about much is a tray monitor. It sits in the system tray, and you can open it up and you can see real-time activity in any of the daemons that you want. And here is sort of a picture of most of the components. The user usually interfaces through the console, which talks to the director. And then let's say you're doing a backup job. What happens? The director will contact the storage daemon, say, I want to run a backup job. The storage daemon will ensure that it's a director that's capable or authorized to do that. It will then send back authorization codes, etc. The director will then contact the file daemon, give him the list of files to back up, and anything else it needs. For example, it may say compute check some codes, SHA1 code for each file or whatever. And then the file daemon will contact the storage daemon, and once they've authorized each other, it'll transfer the files and the data, all the data on the files, and all what I call the attributes, which is essentially a stat packet that contains the file name and the time and date it was the last change in that. The storage daemon then in turn puts the information on whatever device you have selected for that job. And at the same time, it sends the file attributes, the file name and the time and date stamp and the size and a few other things, and the storage location back to the storage daemon that'll put it into the catalog database. And with that sort of a scheme, it makes doing restores really quite quick. Now I'd like to give you sort of a summary of a few of the features. As I said, the basic philosophy of Bacula is that it's centralized. All the decisions are made by the administrator and centralized in the Bacula director. Everything communicates by the network, so the pieces can be anywhere. It's not important. Normally, they're all located on a local network. It has its own scheduler, so it can run jobs automatically at night. It can run simultaneous jobs with priorities. It can reschedule jobs if they fail, etc. The restore is interactive. It's always interactive. Typically, you'll want to restore a piece of the current backup, the most recent one you did, which may involve many backups, a full backup, differential, and other backups. You can restore to prior dates, or you can restore just a file or directories or whatever. And once it's installed, most administration is done through the console. Very simple. Bacula all tapes, all disks, all volumes that Bacula uses have their own Bacula own label, so that Bacula will never overwrite data accidentally. You could, of course, another job could come along and open the tape drive and write on the tape if it can, but I don't have any way to stop that. It supports ANSI IBM labels, which means that if you're running in a big shop, Bacula will coexist with other programs and gigantic auto changers. The format of the volume where the data is stored is Bacula own format, well documented and extensible. We support Unicode for Win32 and UTF-8, which is the same on Unix machines, so there's no problem with virtually any foreign language. There's a Python interpreter, if you configure it, built into Bacula, which means a user can get control at strategic points during a backup and carry on various things. And as I said, there's a rescue CD-ROM. Backups can obviously span multiple volumes. I couldn't imagine a backup program that doesn't allow writing across multiple volumes. You can put any number of backups on a volume. They can be backups from multiple clients, from multiple operating systems. Bacula doesn't care. The storage daemon doesn't care. It knows very little about the information that's going on with the tape. Most tape drives are supported because we have a configurable device driver. Actually, most drives that you'll find today, modern drives, work out of the box because the default configuration is very simple and works with almost everything. We support auto changers with barcode readers, and Bacula has very extensive what's called pool and volume library management. I won't go into the details of that, but it's very important if you're running a large shop. And then I've mentioned several times that restores are very rapid. Well, one user told me that he used to use tar, and it took him 4 to 6 hours to restore files, to find the files and space down the tape to the right place and then restore them. And with Bacula, he said it works in 3 to 4 minutes, which I think is pretty good, and it's probably a slight exaggeration, but you get the idea. From the very beginning, I built in as many security features as I can, because after all, you have a daemon sitting there, a service that's listening on a port. It's a file daemon. It could potentially transfer all your files someplace. Well, all the daemons authorize each other both ways with a cram MD5 method, which means that they have shared password, but the passwords are never transmitted across the network. There is one password that is transmitted across the network, but it's a temporary password, and I don't think there's any problem with security there. If you want, both the director and the storage daemon can be run as non-root, as well as your catalog database. You can put signatures, hash codes, have Bacula create hash codes for all your files. Every block that Bacula writes to tapes has a checksum on it. You can restrict user access through consoles by giving them different passwords and different authorizations of what they can look at. Bacula has built-in communications encryption. Okay, so if you want to work with something across the internet, backing up across the internet, you can, providing you have good, stable communications links. And recently, we also added data encryption as a part of Bacula. And then, obviously, if Bacula can do hash codes, we can do a sort of like a tripwire intrusion. So if anybody uses the package that was discussed previously to break into your machine, Bacula can potentially tell you that your files were compromised and help you get your files back. Sort of the other end of the spectrum. You can see a few of the systems listed up there where Bacula runs, where the client runs. The director and the storage daemon currently run on all Linux varieties, all the Z series, and on Windows. Some of the other systems I've never tried building them. I imagine it can be done. It has a disk spooling capability, which is very useful, so that it buffers the data coming in from the clients on disk before sending it to tape, so that the tape doesn't start and stop all the time. It'll send it in big blocks and avoid the shoe shine syndrome. You can back up POSIX access control lists if you want, Mac resource forks, and all of Windows permissions. From the very beginning, Bacula supported large files and 64-bit architectures. It's been from the beginning also multi-threaded using pthreads. Originally it was written in C, but after a short time, maybe a year, I converted it to C++, but it's a pretty small subset of C. It helps us generate code that's a little cleaner. Now, I'd like to describe what's probably the hardest part of getting Bacula running, and that's the director configuration file. There is a tutorial, an example that runs out of the box that I recommend anybody that's starting with Bacula run, but I'll give you a rough feeling for how it works. Each section of the configuration file in each of the daemons, they all look very similar, has what is called a resource. And the first example up there is a director resource, and the second one is a console resource. The director, when it's in resource, when it appears in the director file, there's only one director. And it means this is who I am. It's the director's name. It tells him his name, and it tells him where he can get scratch file space, temporary file space, how many concurrent jobs you can run, and it has a password that allows consoles to log in. Okay? If you want to have restricted consoles, you can define a console resource, and then you see there, I won't go into the details, some of the commands that, in this case, the only thing it can do is a status. Okay? That's all that user can do. And typically, of course, you'll have a different password. Now, as I said, jobs are the basic structure that Bacula deals with the basic unit. And each one has a unique name. It has a type, which tells it what kind of thing to do, a backup, restore, etc. Then it has a level, which gives you more detail about what the job's doing, full, differential, or incremental backup, etc. It has a file set, which tells it what set of files to back up. And in the case of a file set, it's a resource. You could create one resource that's used for all your machines, or you could create multiple resources that differ across the machines. Of course, you have to tell it where to get the files, okay, because it deals with a single client for a single job, and where to put the files. And then there's also a thing called a pool, which gives it access. It says, use only volumes that are within that pool of volumes. Okay, so you can restrict what tapes or what disk it uses. And then finally, it needs a schedule if you want it to run automatically. And I'll give you examples of a number of these. Here's a job. As I say, it has a name. This job's called laptop, a dummy name. Theoretically, it backs up my laptop. It's a backup job. The client is, on this one, it would be, I have a different name, but I like users to use laptop-fd because when they send in bug reports, I know that it's a file daemon. All the messages from the various daemons look similar, but by postfixing dir, fd, and sd, we can easily tell what daemon generated the messages. The client, file set, schedule, and storage messages and pool all refer to other resources, which are written much the same way but expand out, have a lot of different information in it. Okay. For example, here's the client resource. The key thing here is the address of where the client is. Okay, and this is a domain name, but you can put in an IP address, either IP4 or IP6 if you want. Also, since we support multiple catalogs, you have to tell it what the catalog is, and you have to tell it the secret password so that the director can authorize itself on the client. The client will let only directors that it knows about enter, and only if they have the right password. The file set is fairly complex. It allows you to include, exclude files or directories using regular expressions, wildcards, and can be very complex. It allows you to turn on compression and various other features that you can see listed there. I'll give you a real example, which is here. A little bit complicated. The main thing is, as with all other resources, it has a name. This one's called full set. And then if you look down where the files are listed, you'll see Bacula normally does not transfer across file systems. It restrains itself to a single file system. That's to prevent recursion. You can turn it on if you want. So on this particular system, I have 3 file systems, the root file system, user, and var. And so I tell it to back up those 3. I also tell it to exclude a few files that I don't want it to ever try to restore. Trying to restore prop or sys won't work too well. And then the options, you can have multiple options that apply to the files that it's going to back up. Every time it sees a file, it'll apply those options. In this case, it's not particularly useful, but I've told it to exclude all files that are .c files and all files that are .txt files. Okay, that's what it does. Sorry, I crammed all the lines together. Normally I'd have them on separate lines, but it doesn't fit very well on a presentation slide. Bacula has a pretty flexible C-like syntax, so that works. The schedule, this is probably the only schedule that's ever needed. People generate monster schedules, very complicated. There's a lot of things you can do, but this one is what I call the weekly cycle. Maybe it should be a daily cycle or a monthly cycle, because it does a full backup on the first Sunday of the month. Then it does a differential backup, which backs up all files changed since the last full backup every Sunday on the 2nd through the 5th Sunday of the month, assuming there are 5 Sundays. If there aren't, it doesn't do that one. And then every other day of the week, it runs an incremental backup. That's what I use for all my backups. And the only thing I do differently is each machine, I stagger the day on which it does the full backup and the differential backup. So one machine, I run it on Sunday, one machine Monday, one machine Tuesday, etc. And that helps spread the load over the week, because a full backup will generate a lot of data. Okay, that's the end of the director configuration file. Now I'm going to show you a file daemon configuration file, which looks much the same. And this is, with one minor exception, this is about all you need. There's very little that you have to change, except maybe the name of the file daemon. And you tell him where he can get working space, and then you give it the name of the director that is allowed to enter that file daemon. You can have multiple director statements, which means you can have multiple directors that access that file daemon if you want, and for each one a password. Okay? Very simple. And in the storage daemon, likewise, it has to know who it is, and then it has to know what directors can contact it. Okay? Since the file daemons never contact storage daemons, it doesn't need to know about the file daemons, because it always contacts them. So in this case, I've defined the name of the storage daemon, and I've defined the name of the one director with a password that is allowed to contact it. Now, the storage daemon, you have to define devices, so it knows where to put the data. In this case, I've defined a very simple file device. You see a few of the directives that you have to give it to do that. Basically, you provided a path to a directory that already exists where it's going to put the volumes. The volumes will be named with the name that you give them, and away it goes. It's real simple. Something a little more complicated is an auto changer. Okay, we've defined the auto changer at the top. The name that you give to that auto changer is the name that will be used inside the director to reference this thing. And I've specified 2 drives, drive 0 and drive 1. So this auto changer is an auto changer with two drives to read or write tapes simultaneously if you want. And then I've defined one of the devices. As you can see here, I give it a drive 0 as the name, and the archive name is typically the name that, in this case, that Linux uses to access the drive. Okay? Very simple. There'd be another similar name with a few different changes so that the director, the storage daemon knows how to reference it. Okay, that's about all I'm going to tell you about the actual working of Bacula. It's not much, but hopefully it gives you kind of an overview of it with a concept of sort of general idea of configuration files. I have to say, most developers don't think that backup programs are very sexy. We have a lot of trouble attracting developers. And maybe they're right. One thing I can tell you, backup programs are extremely complicated. For example, we're dealing with databases, SQL. We're dealing with GUIs of all kinds. We're dealing with web, writing a GUI web interface that puts up information from an SQL program database is non-trivial. We deal with networking, and it's critical to this application because we have to get the data across the network very fast. We deal with OS at a very low level as well because we have to basically back up and restore every bit on a file system. And that's not so trivial. And then there's all kinds of algorithms. For example, let me give you one quick example, the directory tree. When you do a restore, it creates an in-memory directory tree. There may be something like 100 million records that come in if you've backed up, say, for 6 months with one full backup, a bunch of differentials and I lose the word now. Anyway, some other backups. And so 100 million records may come in. You need to sort them out and reconstruct the directory tree, which is not so trivial. Well, the original version that I wrote was a linked list that created a directory tree. Just recently, I converted it to a red-black binary tree, okay? A non-trivial program. And it speeded up the creation of this in-memory directory tree by a factor of 513. So algorithms are very important in this process. Everybody wants to know where we're going. The best thing is to look on the website. Key things are they want to be able to restore files very accurately, which Bacula doesn't always do. Every time it backs up a file, if you delete it and you do a full restore, it will restore that file. This is a problem that virtually all backup programs have that are based off of time and date, as Bacula is, etc. You see, unfortunately, I don't have the time to go into the details because I'd like to show you a demo. The main thing to remember is the website, www.bacula.org, and you can see a little bit about how things are developed. We have a subversion database, a subversion repository on SourceForge, and all patches that come in, I personally review them. The developers commit themselves, and I usually look at their code, but they're very good about it, so it just works by itself. I'm not a gatekeeper, though. The license is a GPL2, and one of the things that we did recently was transfer the license via the fiduciary license assignment to the Free Software Foundation Europe. So the copyright is now maintained by them, which is a big load off of my back because they maintain all the paperwork, and if there's any violations of our license, their task force very generously will protect us. They have the lawyers and they have the resources needed to make sure it works. And since this isn't a commercial venture, I have no need to have private licenses. Again, the key thing is to look on the website, www.bacula.org. Everything is there. I can tell you the one thing you don't want to do, somebody told me, don't try to print out the manual. It's 800 pages. It's a good resource, and you need to read the manual, but don't try to print it out unless you know what you're doing. And then also this presentation is there as well, okay, if you just go to the right links. Now, that terminates this part, and I'm going to do, let's see, how do I shut this down? In show. Now, here's where I'm going to do something I should never do. And I'm going to try to run a real live demo. I think I have a few minutes, don't I? Okay. So, can you still hear me? It's going to be a little difficult to... I can keep it here. I'm going to start everything from scratch, okay? Okay, so I've started up MySQL, and I've started up Apache server. you don't need to see them. There's nothing really super there. And then I'm going to start up just a copy of Bacula. It happens to be a development copy, so I hope it doesn't do anything wrong. Normally, yeah, right. Under the pressure of being on front stage, I can't even type. Okay, and now I'm going to start up Firefox. Normally I use Comfort because I run on KDE desktop, but for some reason it doesn't paint things too correctly, so and it works on Firefox. Now, unfortunately, I think I mentioned at the beginning, this is a little machine, old machine, 700 megahertz, 256 megabytes of memory, so everything runs slowly. Here is a picture through the web server. I just pointed directly at the local host here that shows what went on for a week ending, I think it was on Thursday morning. I copied down from my site, my own production site, and you can see the different clients, the different jobs that ran here. There were not a lot of them running because I've been away from home for a month, and so I've closed down most of them. But you can see the backups there that have gone on. It shows you when they started, the amount of time they ran, the number of files they changed. Okay, for example, Rufus is my developed machine. Even though I wasn't there, there were 123 files modified that were backed up. And then there's some statistics here. Now, what I'd like to do, if it works, I'm going to just minimize this. And I'm going to just run. So you can see here, as I'm going to run as non-root. Here's the console. And fortunately, it all connected. And I'm going to just run a job that I've sort of trumped up here that's going to back up this particular machine, one directory, not a lot of files, I think we'll see, and it's going to back it up to disk rather than tape. Okay, the backup jobs you saw there will back up to LTO2, but I don't have an LTO2. Okay, so I just told it back up. I could have changed all the information. You see it running real time. I think it takes a minute or two. And then what I hope to show you is in the web report, show you that it actually sees that the job ran and show you how you can see the job output for that job as well. And then I'll show you, if you're interested, a few of the other features of that web backup. How much time do I have? Okay. So, as I told you, this is a slow machine. Normally, this runs on my desktop, my developed machine, in about 10 seconds. Here, I think it takes a minute, which seems like an eternity when you have 300 people looking at you. So, anyway, I can see one thing Bacula does is when it gets really active, it can use your CPU a lot. For me, it never disrupts me using the system, but I'll tell you, it's something you do want to run at night. It's not, okay, there you see the output, and I'll go through this just a little bit more in the thing, but in the other one, oh yes, I forgot to skim down the file. So we backed up 81 megabytes here, okay, 5,500 files, okay, in 1 minute 14 seconds. Okay. Now, if I can find my browser, Conquer, no, here. Okay, here it is. This is Timmy. This is a new entry. And as you can see, it ran on the 25th at 12:49. Okay. And if I click here, it's the only one that I can click on because it's going to go off and talk rest of the daemons are not online. This is the job output that we just saw, but it's pulled it from the catalog. So for all those jobs, this information is saved in the catalog. And the same thing, you see it's 81 megabytes was backed up, 5,500 in one. It's exactly the same output. The output within Bacula you can direct either to via email, to a log file, to just a disk file, to the catalog. You have full control over that. You can send it in multiple places to multiple different people depending on exactly what kind of output it is. If I come back here and I click on clients, this shows a list of all the clients that have been backed up over the period. And if I show you a list of the last jobs, okay, this is a list of the jobs that ran this week. And theoretically, you can click on any one and you get back to the information. And then media, I'm going to look at all media. And you see, this is where my backup normally goes, into those LTOs. It's on an auto changer, dual drive auto changer. And you can see two LTO1 and LTO3 are full. And you can see when they were first written and when they were last written. There's a huge amount of other information that's kept that you can pull out if you want. The current one it's working on is LTO4, which is still in M mode. And as you can see, well, probably by now it's closed that one out and started up a new one if I had access to the real data. And then finally, you see down at the bottom is a file instead of an LTO, and that's where I did the current backup. I've done a few test ones, so the volume bytes is much bigger than the 81 megabytes or 89 megabytes that we actually did. Okay. And that's about it, I think. There's a lot more features I could show you, but you get the idea. And hopefully in the near future we'll have an interface, a GUI interface that will allow you to go in and really look at all parts of the configuration and interactively modify the configuration and whatever. So, thank you. Yes? Okay. If there's any questions, I'll be glad to take them. Schedule for? Well, the question was, is there any information on the schedule for the BAT interface, the new one I'm working on? And one of the things that I say, I'm an open source developer. I'm not paid anything to do development, so I refuse to set deadlines. However, I think it already exists today, and if I can, I'll just launch it here. It doesn't do anything, not much of anything, but I think in 6 months it'll be in good shape. Okay, so if we're lucky, yeah. There you see a rough idea of what I'm planning on doing with things such as restore and run a job, which brings up a window much like the one you saw. And the idea for this will be that there'll be all sorts of resources listed down here that you can click on. For example, if you click here, it's a different way of doing a restore than here. And you can have multiple consoles, which means you can connect to different directors if you want. Okay? So probably 6 months. Did you have a question? Yes. Yeah, the question was, if you use disk storage, can you say use only this much of a disk? Yes, you can define how many volumes you want to create in a pool, and you can define a size for each of those volumes. Normally there's a default size that comes with the pool, and that's what it'll use, which is infinite, which means if you don't fix the size, your disk file is going to grow and grow and grow. But you can fix the size, and then after you've created the disk, if you want, you can manually adjust it to whatever you want. So you have a lot of fine control. I'm sorry, I didn't hear you. Can it create a snapshot before it does a backup? Is that your question? Can Bacula do a snapshot before it does a backup? On Linux systems, no, because no one's really asked for it. On Windows systems, yes. On Windows, on the current version, the default is to do a volume shadow copy, okay, providing the system supports it, which is a snapshot that's done, and any changes to the system get put in there, and Bacula backs up from that. Bacula has a mechanism by which you can run a script file before a job and a script file after a job. And during those script files, you can do anything you want. Okay? In fact, we're working on so that if you really want, you can run a script that modifies what files Bacula will use to back up. So that in that sense, users can have control of their own files. I don't particularly like that idea, but we're going to try to provide all those kind of features. There's a question here. Yes, yeah. Linux has things such as LVM that really accomplish the same thing. Yeah, the question is, what kind of compression are we using? Normally, Bacula doesn't do compression. We rely on the hardware to do it. Tape drives have very good compression. However, for disk files, Bacula can do compression on the client, and it's zip. It's gzip, in fact. You can set the level between 1 and 9, but that's the only one we have currently. Okay? Question? You could use your? No. The question was, does Bacula authorization use standard methods? And the answer is, it uses standard algorithms, okay? But it has its own communications protocol, which is a block protocol, okay, first. It's not a stream protocol. It sends blocks of data. And second, it's its own code. So if you want to authenticate Bacula, a daemon with it, if you want to communicate with it, you need to write some special code. But people have done it already from Perl, and it's very easy to do. Sorry? The question is, have I considered Kerbos? Yeah, no. If somebody wants to implement it and send us a patch, yeah, why not? I put in a simple authorization method that worked pretty well, and no one's complained about it. If the one thing is, if the authorization fails, it blocks any other authorization attempts for 5 seconds. So if you try blind mode beating away at it, it'll take you a long time before you get in. How does it handle? How does Bacula handle open files? On Windows, it uses volume shadow copy, which takes care of the problem. It's sort of like a journaling system. Once the snapshot's been taken, every change is journaled, and so Bacula gets a current image of the file. On Linux, we don't do anything. As it was mentioned, you can use LVM, or, in most cases, once you open a file in Linux, yeah, it can grow. Somebody can shrink it, but typically it doesn't get pulled out from under you like it could on other systems, and so the backups are pretty good. Bacula will tell you, if you ask it to, if a file has changed during the backup process. That's not actually in a released version. And when it restores a file, it always checks to see if it has the same amount, that it restored the same amount that it found at the beginning of the backup. And so if it differs, at least you'll know about it. Okay. Question? How does Bacula handle scheduled jobs where the job fails because the client machine is down? There are directives within Bacula that tell it to retry the job X times, where you define X times after a certain interval that you define, and so you can do it. There's still other features that we want to add in the future. For example, right now, if a Bacula gets stalled for one reason or other, an operator doesn't change a tape, let's say, and so a bunch of jobs are sitting there waiting for the tape drive, and then 48 hours later, there's a new set of jobs waiting for the tape drive. Well, they all run, okay? And so at some point, we need to make Bacula smarter so that it knows that if there's a full backup running and then an incremental backup comes along, it probably should terminate the incremental backup. But that will be an option, user option always. Sorry? If you lose your SQL database, is it easy to recover from? It's not very pleasant because there's a lot of information in there. Particularly, the most important information is what jobs and what are on what volumes and what volumes you have. All the historical information. If you are careful, you wrote what I call a bootstrap file. You did a backup. If you use the standard Bacula out of the box, okay, every night it'll come up and it'll do a backup, and then it'll back up the catalog. Okay, and in doing so, it'll create two files for you, two bootstrap files. One is a bootstrap file for the backup, okay, which is sort of like a condensed ASCII file that you can feed to the restore process that will restore all the files that were backed up. The other one is the same thing for the backup that you did of the catalog. So if you have that bootstrap file, you can go and get very quickly your catalog and restore it. Okay? There's also another method, which is really painful, and a lot of users use it. There's a thing called bscan, where you point it at a set of tapes, okay, or a set of disks if you want, and Bacula will read through those Bacula tapes and will reconstruct a database. Okay? It assumes that you've created a dummy database at the beginning, but you need to back up every night your database, okay, along with your data. You should also back up your configuration files because they're not always so easy to reconstruct or find on tape. Bacula version 2.0, which was, and above, actually we're up to 2.2 now, the 2.02, can do what we call migration, which will, on a job-by-job basis, read the data on one volume and transfer it to another volume. And so you can do disk-to-tape migration that way. The question was with different retention periods. Okay, well, the current migration deletes the information in the original file. The second file, the second backup of that job, it takes on the characteristics of the job. It looks like it ran at the time the original job ran, etc., but it's stored on a new volume. And so it has all the retention periods and times from the volume you put it on, not the original one. Okay, so it follows logically. Could you talk a little louder? The question was, if I understood it, can Bacula reconstruct a full backup or the current state of the system from a full backup and then incremental backups? Yeah. Yeah, he's asking if you can do a full backup once and then thereafter do incremental backup. The problem with that kind of a scheme is that you have a full backup you need to access. If you did it a year ago, how many incremental backups? You may have hundreds and hundreds of tapes that Bacula has to read through. Okay, I think... Yeah, okay, now I understand what you're asking. He's asking if you can take those old full backup plus a bunch of incremental backups, put them together and create what's called, if I'm not mistaken, a virtual full backup or something, a synthetic full backup. And theoretically it's possible. I haven't implemented it yet. It's a rather trivial, now that we have migration, it's a rather trivial enhancement that we'll be making. The answer is no, you can't do that today, but within 6 months, yes, Bacula will be able to take a set of tapes automatically. You can do it manually if you want, but it'll be able to automatically take a set of tapes that represent the current state of a client, let's say, and generate one new backup that has only the current files in it, as if that were a full backup made today. Which is, at first thought you might say, why do you want to do that? Well, there's a lot of shops where uptime on a particular machine is critical. They don't want to spend the time, they don't want to have a backup process running during the time it takes to do a full backup. So they would be very happy offline on another machine, condense the backups into one single full backup. Russ? Yeah, he's asking if that'll have the same problem with deleted files when you do restore, because Bacula backs up files on their time and date, and in any file that you deleted before the current time, if you do a full restore, will come back. And that is a project that's number one on our list of things to fix. It's a bit compute intensive. It takes some time. You actually have to go access the catalog every time you're going to back up a file, or you have to send the full data from the catalog so that it knows what files are backed up, and then it can choose. And that'll be coming, yes. Okay, and it'll also solve the problem that you suggest. I think we have time for one more. One more, okay. What's on the Bacula Rescue CD? The Rescue CD is a little different from most Rescue CDs, and I hope to work with some of the Linux distro suppliers to change that. The problem with current Rescue CDs is your disk goes down. Your partition is dead. Your disk is dead, you replace it with a new one, identical size. Well, if you're like me and you have 5 or 6 different machines, or if you're in a big shop with 2,000 of them, and half of them are partitioned differently, how do you get the partitions back? The Bacula Rescue disk does something, well, with a regular Rescue disk, it's no help. all of a sudden you're booted and you're in a command shell and you don't know what to do. You don't know anything. Typically they don't even mount the disk for you. Well, Bacula Rescue CD will, when you create it, it takes a snapshot of your system. It tries to use your kernel so that you're familiar with it. And then it takes a snapshot of all the critical data on your disk, and it saves that onto the CD. And so when you start up that CD, providing you have the instructions already printed out, with not a whole lot of problems, you execute a few scripts and you can go out and have it totally repartition your hard disk, reformat any of the partitions and whatever. And it's an aid to getting you back. The process of recovering a system from bare metal is non-trivial. I mean, if you have your director, your catalog, and your storage daemon on the system that went down, it's not a simple process to get all those things back up so that Bacula can restore. You're much better off having a second system with a temporary director, if you want, and a storage daemon, and you then fire it up and you put only a client, a static client on the machine that's broken, and so you use that to restore all your files. That's a pretty simple setup. I'll be around so I can answer more questions if you have them, but we've run out of time. Thank you very much.